We want to look at another important topic referred to as mathematical induction. This is part one of it. We'll do the part two as time goes on. What is mathematical induction? It's a technique of proving a statement, theorem, or formula which is thought to be true for each and every natural number. Now the question is, how do we solve this mathematical induction? Before then, we have what we call the base value and the hypothesis. The base value has to do with the value of n, initial value of n, and the hypothesis has to do with the value of n is equal to k plus 1. Now, but you look at this, step one of it. It's a very simple mathematics, very, very simple. Step one, you consider an initial value for which the statement is true. In that case, n will be equal to the initial value. Most cases, the initial value can be 1 or 0, but most cases they also use 1. Step 2. This step 2, you should take note of it. You don't need to bother your head about it. It's an assumption. Step 2, assume the statement is true for any value of n equal to k. Now this k can be any positive integer like 1, 2, 3, 4, and so on. So it's an assumption. It is not true in the real sense, but you assume it to be true. So don't note the statement assuming. But this number 1, you definitely have to prove it that it's true. But this number 2, you assume it. Then number 3, then prove again that the statement is true for n equal to k plus 1. That is, since you assume that n is equal to k, in step 3 of your solving this mathematics, you now prove that n is not just only equal to k, but it's equal to k plus 1. When you are able to prove that n is equal to k plus 1, and you prove also that n is equal to 1, then that means that that particular statement is true with regard to the all cases involved. So you now say that the induction is true in all cases. Like when we start solving it, you will see how it is done. It is a very simple mathematics. Now note, you actually break n equal to k plus 1 into 2 parts. One part is n is equal to k, which is already proved, and then try to prove the other part. Now this is where most students usually have problem. But in this video, I will spend time to demonstrate how you can split the parts when n is equal to k plus 1. I will really spend time because this is where the students normally have issues. And it's also very, very simple. Remember, it has 3 steps. Step 1, n is equal to 1. Prove. Step 2, don't prove. Just assume that the statement is true for any value of n equal to k, where n is a positive integer. Then step 3, you now prove that that statement is not just true for n is equal to k alone, but it's also for n is equal to k plus 1. And when you get to k plus 1, at a point, you will split it into 2 to bring out the first one, which is n is equal to k, and then try to prove the other parts. If they are the same, then that means it is true in all cases. Now let's look at another interesting question. Show that 1 plus 3 plus 5 plus 2 bracket 2n minus 1, those brackets equal to n squared. Show that using the principle of mathematical induction. So how do we do this? Simple. Follow our procedure. Step 1, we want to say that it is true for n equal to 1. I want to prove that it's true for n equal to 1. So what do I do? I'll just write 2n minus 1 equal to n squared is same thing as saying here now. That will give me 2 times n is what? 1 minus 1. Let's see what it will give me. It will definitely give me 2 times 1 is what? 2. 2 minus 1 will give us 1. To give me 1 squared. And 1 squared is still 1. So it is true for n equal to 1. It's a very simple mathematics. So step 2, we now want to assume, remember that this one is an assumption, assume that it is true for n equal to k. So what will I do now? I will substitute this n by letter k. So what I will have here is 2n minus 1 is equal to n squared. Is same thing as 2k minus 1 is equal to k squared. K squared. 2k minus 1 is equal to k squared. Okay? So with this information, this is an assumption. I assume that it is true for n is equals to k. So this one is assumed to be true. So I will now step over to step 3. Step 3, I want to prove that it is true for n equal to k plus 1. So what will I do now? Anywhere I see k here, I replace it with k plus 1. So I now have it that one plus 3 plus 5 plus open brackets 2, where I have, okay, from this statement, let me put this one plus 2k minus 1 is equal to k squared. But now I have k plus 1, now it will now become 1 plus 3 plus 5 plus, I'll add this, add 2k minus 1 plus, the next one now, I will now replace it with 2. Now, anywhere I see k, I'll replace it with k plus 1 in this case now. So I have 2k plus 1 minus 1. 2k plus 1 minus 1 all equal to k plus 1 squared. Now notice what I did here for clarity's sake. In this case now, I have 1 plus 3 plus 5 plus 2. 2k minus 1 is equal to k squared. That's this one. But remember that whatever I'm doing, I'm working with this. So this also means 1 plus 3 plus 5 in the step 3 now. Plus this 2k minus 1 plus 2 open bracket k, 2k plus 1 minus 1 equal to k plus 1 squared. Remember that this thing and this thing, they have the same value. But I added this so that to enable me be able to, I've already splitted it here, so it will make it easier for me to get the value here that I will use to equate to this one. So with this, you also notice that 2k minus 1 is actually equal to k2. So from this equation here now, I can take only 2k minus 1 to now mean, let me show you what I mean, bet 2k minus 1 is equal to k2 here, okay? So that means this one now will now become k2, right? Plus open brackets 2 open brackets k plus 1 minus 1 is equal to k plus 1 all squared. So let's bring it up. So, okay, let me finish here. So k squared is equal to 2 times k will give you k squared plus 2k plus 2 minus 1 is equal to k plus 1 squared. Now bringing this statement up here is going to give us k squared plus 2k minus 1, because 2 minus 1 will give us 1, plus 1, that's 2 minus 1 is plus 1, is equal to k plus 1 all squared. So without much ado, this one is a simple quadratic equation. So when you factorize it, it's going to give you, okay, let me factorize it for people that are not used to that. Let me factorize it for you. So that this one now will be, only this one will be k squared plus k plus 1 equal to 0. So factorizing it, you divide by k, bring the k outside. So that will give me k, divide by k, that will give me plus 1. Bring down, divide this one by plus 1, bring the plus 1 outside. Plus 1 divide k will give us k, plus 1 divide plus 1 will give us plus 1. So notice that when I factorize it, the factors will be k plus 1 and k plus 1. Notice that everything here is equal to k plus 1 squared. I'm only doing this for people that are not used to simple factorization. But then when you have k plus 1, it also means the same thing as k plus 1 squared is equal to k plus 1 squared. So looking at what I've done, you can see that without much ado, that it is true. The power 2n minus 1 is divisible by 3 using the principles of mathematical induction. So how do we go about this simple one? Just watch. So what the first thing you do is the first one, that's step 1. Step 1 is prove that the statement is true. That this statement is true for n equal to 1. How do I prove that? I'll simply write 2 to the power 2n minus 1 is the same thing as 2 to the power 2. I substitute n by 1 minus 1, and that will give me 2 to the power 2 minus 1, which is actually 4 minus 1, and that will give me 3. Now the next question is 3, when 3 divide 3, it will surely give me 1. That means the result is true for n equal to 1. In this case, I can make a statement and say that the result is true for n equal to 1. Then the next step, which is step 2, is an assumption step, which I would say I assume that the result is also true for n equal to k. So what does that imply? It implies that I will now substitute 2 raised to the power 2n minus 1 is same thing as 2 raised to the power 2. I substitute n with letter k minus 1. Then we say that it's divisible by 3. So what that implies is that it's equal to 3a, where a is a natural number. What do I mean by that? What I mean is that based on the statements, it means that whatever a is, I multiply it by 3, it can be, if I divide it by 3 to give me, it's divisible. For instance, now if a is 2, now 3 times 2 is 6, divided by 3 is possible. 3 times 4 is 12, divided by 3 will give us 4 is possible. So we assume that a is a natural number. Now with this, we now move to step 3. Step 3, we need to prove that the step 2 statement, which is 2 raised to the power 2k minus 1 equal to 3a is also true for n equal to k plus 1. N equals to k plus 1. So when you look at this carefully, what do? We are going to replace everything here with k plus 1. So I will now have it as, let me call it pk plus 1 is something as 2 raised to power 2 open brackets k plus 1 minus 1. Now, if you look at that very thoughtfully and carefully, you will also notice that we need to open this bracket by saying 2 times k. That will give us 2 raised to power 2k plus 2 minus 1. And going down carefully, it will also mean that if you use the simple understanding of indices, you will know that this thing has to also mean 2 raised to the power 2k times 2 raised to the power 2 minus 1. Coming down, it will give you 2 raised to the power 2k times 4 minus 1. And remember what I told you, that when you get to this point, you will split whatever result you have and bring out step 1, which is already assumed to be, step 2, which is already assumed to be true, and then confirm the other part of it if it is true. If that part is true, then the statement is true in all cases of value of natural number n. So let's split it now and see what we're going to have. That's a very simple mathematics that gives us 2 raised to the power 2k. This I'm looking for, I want to get back this 2 raised to the power 2k minus 1. I want to get it back, this. Okay, so I will split it in this form. So I will now have 3 plus 1. 3 plus 1 will give me 4, right? Minus 1. Now, 2 raised to the power 2k times 3 will definitely give us 3 times 2 raised to the power 2k. See that? Then 2 raised to the power 2k times plus 1 will give me plus 2 raised to the power 2k. So the bracket is open now. Then you now have minus 1. So if we look at it now, we have 2 situations here, 2 parts of the result we have in step 3. We have 3 times 2 to the power 2k, which you know that in agreement with this, if you divide this by 3, since 3 is here, that means it is true. Okay? And then 2 to the power 2k minus 1. If you look at the assumption in step 2, we already assume that it is true. It's equal to 3a. So which means that in both in part 1 and part 2 of this, my equation that I splitted, it is all true based on this equation, this statement here. So with this, using the mathematical induction principle, I can be able to state clearly that it is true in all cases. It is clearly true in all cases. Okay, let's look at this exam question. Show that 3 to the power n minus 1 is a multiple of 2 for n equal to 1 and 2. Now, the first thing is to prove that the result is true for n equal to 1. How do I prove that? I will simply write 3 raised to the power n minus 1. I will now substitute it to 3 raised to the power n becomes 1 minus 1. That will give me 2, because 3 minus 1 is actually 2. So we can see that from the step 1, the result is actually true for n equal to 1. Then I'll move straight to step 2. Then in the case of step 2, the step 2 is the step that you assume, not prove. You assume that the result is also true for n equal to k. So what do I do in this case? I will substitute n with the letter k. So what I will have here will be 3 raised to the power n minus 1 is the same thing as 3 raised to the power k minus 1. Now, with this information, remember that this one is only an assumption. So, but I will still need it when I look at step 3 of solving this situation. So let's look at step 3. Now in step 3, I want to now prove. Remember the first one is proof, so someone is assumed, third one is also proof. I want to also prove that the result, the statement is true for n equal to k plus 1. What do I do also in this case? Simple. I will just substitute k by k plus 1. So what I will have here now will become 3 raised to the power k plus 1 minus 1. Now, if you look at this very carefully, you observe that 3 raised to the power k plus 1, using the simple knowledge you have in indices, means the same thing as saying 3 raised to the power k times 3 raised to the power 1 minus 1. Remember, in indices, when common base multiply, you add their powers. At this point, we are almost through. So what next? What will I do next? Remember that I told you in the introductory part of this that you always split that of step 3 to be able to get step 2 and then confirm the other part of it. So how will I split this? I will now put it in this form. I have 3 raised to the power k times, I will split the 3 because I want to bring out something. I'll split it into 2 plus 1, then minus 1. Let's see what it will give us. Now, that will give us 3k times 2 will give us 2 times 3k. That's one part of it. Then plus 1 will become 1 times 3k. That will give us 3k. And then we also have minus 1. Now I want you to look at it very carefully. You notice that I use these 2 to multiply. These are 3k times 2 will give you 2 times 3k, which is this. 3k times plus 1 will give us 3k minus 1. So I put this bracket to show you the 2 parts of this step 3 result. Now these 2 parts, when I look at it, whether it actually proved that n is a natural number it's true that n is a natural number, as a natural number confirms all the situations here. So let's look at it carefully. So you see where you have 2 times 3k actually is correct because a multiple of 2 is a multiple of 2, which means if you divide this number, 2 is one of the factors. This one is already been written as an assumption that it is true. So with this result, it is very clear that the statement that 3 to the power n minus 1 is a multiple of 2 is true for all natural number n. So we can say that it is true that 3 to the power n minus 1 is a multiple of 2 for n equal to 1, 2 in all cases. It's okay.